With over 1 trillion galaxies left for humans to explore, we've only just begun to glimpse the complexity of the nature of life in our universe. Our cosmic neighborhood, our solar system, is here in the Milky Way galaxy. As far as we know, the lives of every living thing ever has been restricted to just one planet in just one galaxy throughout the entire universe. Ours. This has led scientists to ask, just what makes a planet able to support life? What are the ingredients that make a planet habitable? From our habitable home here on Earth, there appears to be a cosmic recipe that, if followed correctly, suggests that life could exist on a planet somewhere else in our universe. We call this the Cosmic Climate Cookbook. The right proportions of just 3 ingredients: energy, an atmosphere, and liquid water are critical for supporting life on a planet. The first ingredient, energy. In our universe, most energy comes from the stars. And there are different types of stars. Some stars are bright and hot, while some stars are dull and cool. Here, we are seeing the bright, hot stars, blue in hue. Now, the dull, cool stars, red in hue. Our sun, the source of energy in our solar system, is somewhere in between a hot and bright star and a cool and dull star. The second ingredient, atmosphere. An atmosphere full of different gases that trap heat can support a habitable planet. Because of our atmosphere's natural ability to trap the sun's energy as heat, the Earth's usual temperature is somewhere around 59 degrees Fahrenheit. Without our atmosphere, the sun's energy would escape back into space, and the Earth's temperature would be somewhere near 0 degrees Fahrenheit. In other words, without our atmosphere, the Earth would be a big cold rock. The third ingredient, liquid water. Earth's surface is about 75% water. From the massive salty oceans to the freshwater lakes and rivers, liquid water is a basic requirement for life as we know it. If the Earth were too far away from the Sun, like Saturn and Jupiter, all of our water would freeze. If, on the other hand, Earth were too close to the Sun, like Mercury, our water would completely vaporize. Lucky for us, we're somewhere in the middle, where water can persist as a liquid at the surface of our planet. This region is what scientists call our solar system's Goldilocks zone. This distance from the Sun is just right to be habitable if the other ingredients in the Cosmic Climate Cookbook are in the right proportions. Only 3 planets in our solar system are in the Goldilocks zone. Let's investigate these planets closer to see if they can be habitable. Venus has a thick atmosphere that is always full of clouds. Spacecraft flybys have revealed that the clouds on Venus are not made of water vapor like they are here on Earth. They are actually made of sulfuric acid. In other words, they're clouds made of battery acid. As far as we know, battery acid is something that most life forms would prefer to avoid. Most of the gas in Venus's atmosphere is carbon dioxide, a potent heat-trapping gas. The amount of carbon dioxide in Venus's atmosphere is so great that the entire planet is a volcanic desert, where the average temperature soars to nearly 900 degrees Fahrenheit. That's a heat wave hot enough to melt lead. Scientists think that at some point in Venus's history, it could have been habitable. But all three of the ingredients in the Cosmic Climate Cookbook probably changed to make it uninhabitable. One idea is that as the young sun matured, it got brighter and increased the amount of the first ingredient, energy. More energy warmed Venus until liquid water evaporated rapidly, creating more clouds, and in turn trapping more heat, which then changed the second ingredient, the atmosphere. Eventually, these gases combined to create a runaway heat-trapping gas effect that forced Venus's temperatures higher and higher until all of the liquid water was vaporized, and the planet's climate became uninhabitable, making Venus a most unlikely place to find life, at least for now. There is another potentially habitable planet in our solar system, another planet that may have gotten the Cosmic Climate Cookbook just right in the past. The red planet, Mars. Mars is a dry, dusty, and cratered planet, much more like our moon than the Earth. However, spacecraft flybys have revealed intriguing hints of a wetter past. Dry river channels spotted from orbit, and minerals that form only in the presence of liquid water provide evidence for flowing, babbling, and rushing liquid water on the surface of Mars in the distant past. Several billions of years ago, nearly half of Mars may have been completely underwater. Scientists think that this water came from ancient volcanoes tapping into underground water sources. The ancient Martian atmosphere, much thicker and full of heat-trapping gases at that time, would have allowed the water to remain a liquid on the surface. But today, water can't persist in liquid form on the surface of Mars. Just what happened to all of that water on Mars? Scientists have a few ideas. For one thing, Mars is farther than Earth from the Sun, so Mars gets less of the Sun's energy, the first ingredient in the Cosmic Climate Cookbook. More importantly, Mars's atmosphere, the second ingredient in the Cosmic Climate Cookbook, is very thin today when compared to Earth's atmosphere. Scientists understand that Mars must have lost its water because it lost most of its atmosphere, and the Sun is largely to blame. The Sun radiates charged, energetic particles into space. Also known as the solar wind, these charged particles have slowly stripped the atmosphere of Mars away, molecule by molecule. In contrast, Earth's strong magnetic field guards our atmosphere from the solar wind. Mars isn't so lucky. After a few billion years of cosmic bombardment, the solar wind stripped so much of the Martian atmosphere away that the climate on Mars became uninhabitable for life as we know it. However, humans may visit Mars within our lifetimes with a lot of technological and scientific help. We may then discover the secrets of a once habitable Mars somewhere in the Martian dust. Only time will tell, as NASA scientists and other world space agencies continue to set their eyes on the Great Red Planet. So far, we have learned that the balance of the ingredients in the Cosmic Climate Cookbook is delicate. Small changes to the recipe can dramatically alter the course of an entire planet's history and leave it uninhabitable for life. Our home planet, Earth, has enjoyed nearly the perfect amount of each ingredient in the Cosmic Climate Cookbook for a very long time. Earth has been habitable for most of its 4.6 billion year-long life. Putting this into perspective, if the Earth's 4.6 billion year lifespan was the size of a football field, life appears near one goal line, while modern human civilization would only occupy the tip of a blade of grass at the very edge of the opposite end zone. So let's fast forward through the rise and fall of countless species, a few mass extinctions, a lot of continental drift, and here, human civilization at night. More than 7 billion human beings live right here. Human civilization has expanded so rapidly over the last 150 years that virtually all climate scientists agree that we're now rewriting the natural balance of the Cosmic Climate Cookbook. Humans have been dramatically changing the second ingredient, the atmosphere. Burning fossil fuels like coal, oil, and gas adds heat-trapping gases to the atmosphere. And since the Industrial Revolution, humans have powered our homes, businesses, and vehicles with these fossil fuels. Now the entire global economy relies heavily on burning fossil fuels for energy, and human activity is disrupting Earth's natural balance of heat-trapping gases. Using ancient atmosphere trapped in tiny bubbles in Antarctic ice, scientists have looked into the past, showing just how rapidly humans have changed the atmosphere in a short period of time. The far left side of this graph shows how much of the heat-trapping gas carbon dioxide was in the ancient atmosphere 800,000 years ago. On the far right of the graph is the present day. When humans began burning fossil fuels rapidly around 1850, this graph shoots upward as we added heat-trapping gases to the atmosphere at an extremely unnatural rate. Scientists now know that humans are changing the atmosphere faster than the Earth has done naturally on its own for millions of years. According to our cosmic neighbors Mars and Venus, even natural changes to an atmosphere can impact long-term habitability. So let's take a closer look into Earth's natural history so that we can better identify how dramatically humans have impacted the Cosmic Climate Cookbook. This is the Earth as it was at the end of the last ice age, almost 20,000 years ago. Back then, a 2.5-mile thick ice sheet, called the Laurentide ice sheet, covered Canada and a large part of North America. Many of our cities today would have been under thousands of feet of glacial ice. The Ice Age froze so much water that global sea level was nearly 300 feet lower than it is today. The Chesapeake Bay Basin, now filled with nearly 18 trillion gallons of water, would have only held puddles after rainstorms. You may think that we've only had one ice age. In fact, over the last million years or so, the Earth has experienced around 10 different ice ages. But why? Over a very, very long time, hundreds of thousands of years, the way that the sun's energy, the first ingredient in the Cosmic Climate Cookbook, is balanced over the surface of the Earth changes. How does this happen? Three physical phenomena account for these long-term changes: Earth's tilt relative to the Sun, Earth's wobble on its axis, and the shape of the Earth's orbit around the solar system's center of mass. Earth's tilt gives us our seasons. When it's summer here in the United States, it is winter down in New Zealand. Today, our tilt is about 23.5 degrees. Over the last million years, however, Earth's tilt has changed from more tilted to less tilted every 40,000 years. Much like a spinning top, Earth cyclically wobbles on its axis every 26,000 years. Earth's wobble, along with a changing tilt, can accentuate the intensity of Earth's seasons. Earth's orbit is eccentric or egg-shaped and not circular. It takes about 100,000 years for the eccentricity of our orbit to go from more egg-shaped to more circular and back again. Right now, our orbit is fairly circular compared to times in Earth's recent past. Eccentricity affects how far away and how close Earth gets to the Sun during its orbit. Scientists refer to these extremes as perihelion, the closest point in the orbit, and aphelion, the farthest point in the orbit. These three changes to our orbit work together to make Earth's climate switch between long periods of cooling, resulting in large, thick ice sheets, and relatively shorter times of smaller, thinner ice sheets during warmer periods. These natural climate changes are too slow to experience during the average American lifetime of 79 years. In fact, these changes happen over 10,000 times slower than a human lifetime. Climate change is happening for a very different reason today. Human activities are increasing heat-trapping gases in the atmosphere at unnatural rates, causing the Earth to warm up dramatically in just over 100 years. There are natural sources of heat-trapping gases to the atmosphere, however. The great engines of the Earth: volcanoes. Although volcanoes are one natural source of heat-trapping gases to the atmosphere, humans emit almost 135 times more carbon dioxide every single year than all of the volcanoes on Earth added together. Here we're looking at the locations of all of the active volcanoes on Earth. A large volcanic eruption, like the one that happened on Mount St. Helens in Washington State in the 1980s, would need to happen every 2.5 hours, every single day, for an entire year, to match just 1 year of human emissions of heat-trapping gases. In other words, humans emit 3,650 Mount St. Helens worth of heat-trapping gases every single year. So, humans are clearly changing our atmosphere, the second ingredient in the Cosmic Climate Cookbook. And because these heat-trapping gases, well, trap heat, our planet's temperature has been going up along with them. This globe is red where the Earth is warmer than normal, and blue where it is cooler than normal. Over time, much more of the globe has turned red. 3 recent years, 2014, 2015, and 2016, were warmer than any other year on record. From 2001 to 2016, every year was among the top 15 warmest years we've ever measured. And the 1980s, 1990s, and early 2000s were the warmest decades we've ever recorded. Are we seeing a trend here? Earth's temperature is going up, but how does this impact the habitability of our planet? First, rising global temperatures shrink ice around the world. Arctic sea ice extent has been declining steadily over the last 40 years and is at its lowest extent in the last 150 years. Scientists have observed this trend by reading old ship logs from early expeditions, local records, and from pictures taken directly by NASA satellites in space. Why are scientists concerned about this? Without the Arctic sea ice, dark ocean water is exposed, which absorbs the sun's energy better than white ice, causing the ocean to warm up faster. We all know that when you wear a dark shirt in direct sunlight, you're going to be much warmer than if you wore a white shirt. This is because white surfaces reflect the sun's energy better than dark surfaces. Scientists understand that an ice-free Arctic will have cascading effects on climate patterns for us here in the United States. Not only is Arctic sea ice shrinking, but ice on land, like mountain glaciers and the ice sheets on Greenland and Antarctica, are shrinking too. Red colors on this animation represent places on Greenland's ice sheet that are shrinking. Much more of Greenland and Antarctica's ice sheets are shrinking now than ever observed before. Why are scientists concerned about this? Well, water from melting ice on land runs directly into the ocean and makes global sea level go up. Global sea level is also rising because of our warming ocean. As water warms up, it expands to fill a greater volume. Think of a pot of boiling water on your stove at home. Melting land ice and the expansion of the warming ocean are the main reasons that sea level has gone up globally recently. Any coastline that is colored red on this globe, home to nearly 1 billion people, faces the impacts of sea level rise. Here in the United States, coastal cities like Norfolk, Virginia, are already experiencing more frequent flooding days due to the 1.5 feet of sea level rise that has occurred there since 1900, causing some people to relocate to higher ground. A warmer ocean also means something very important for those of us who don't live near the coast. It makes extreme weather events like heat waves and storms more intense and more common. See how weather patterns are related to the colored ocean temperatures? Warmer ocean water is red and yellow, and colder ocean water is blue. Extreme storms form over the red-colored warm water, and as they move northwards, they leave behind a trail of yellow-colored cooler water. This storm absorbed the heat and moisture from the ocean that it then used to fuel its extreme rainfall, flooding homes throughout Southeast Asia. Why is this important? A warmer ocean adds more fuel for storms. A warmer ocean provides more moisture that can strengthen a storm, and a warmer atmosphere can hold more water. This in turn means more intense rainfall that can turn quickly into flooding in our cities. We've already experienced this phenomenon throughout the United States. Scientists estimate that uncommon extreme rainfall events have already become at least 30% more intense over the last several decades, a clear sign that climate change is happening now. Preparing ourselves and our families by having a plan of action for more intense storms and flooding is just one way to make sure these changes don't disrupt our everyday lives. Ultimately, each person contributes to this changing cosmic climate cookbook. So what can we do to reduce our reliance on fossil fuels like coal, oil, and gas? All over the world, countries, businesses, and governments are driving the renewable energy revolution. Solar and wind energies, which do not emit heat-trapping gases, are providing more of the energy that the world uses every single day. We can all support renewable energy projects at our schools, within our neighborhoods, and at our workplaces. But that's just part of the solution. The rest relies on each of us to reduce our appetite for fossil fuels and energy. We can say no to one-use-only plastic packaging, which releases heat-trapping gases when it's produced and eventually pollutes our oceans and riverways. Reusable shopping bags are a great way to start, but where else can we ditch the plastic? We can shop for local foods that don't travel thousands of miles in fossil fuel-burning vehicles to reach our dinner plates. Finding food labels that identify local ingredients is a great place to start. We can reuse and recycle and repurpose things that we can use again. Hand-me-downs and thrift stores are great options for accomplishing this. Most importantly, we need to tell our elected officials that this is important to all of us. It will take our collective action to make the changes necessary, but it can work. It may be too late for habitability on planets like Venus and Mars, but it's not too late for us here on Earth. Together, we can make sure that the delicate balance of the Cosmic Climate Cookbook is returned, so that future generations will get to enjoy this wonderful, unique planet for themselves. Together, we can fix this. We can change the world for the better.